Let's start with a new chapter, which is HCF and LCM. So what is HCF and what is LCM? So basically the full form could be written as, the full form of HCF could be said as highest common factor, and the full form of LCM would be least common multiple. So does the name itself make any sense? So to understand what HCF and LCM, or the highest common factor or the least common multiples, are, we have to know what are factors and what are multiples. So let's start the chapter by getting into those. So factors and multiples. Factors are the numbers which exactly divides a given number. So let's say we have 12 as a number, right? So what are the factors of 12? Numbers which exactly divides the given number 12 is called the factors of 12. That means if I'm taking 2, 12 divided by 2 is equal to 6, and there is no remainder as such, right? So 2 is a factor of 12. We could write 12 as 2 into 6, right? Now we could write it as 3 into 4 too, right? We could write it as 1 into 12, right? So we could actually simplify this into 2 into 3 into 2, right? And this could be factorized as, again, 2 into 2 is 4. So it's again 2 into 2, which is 4, and 4 into 3, right? So what are the factors of 12? What are the factors of 12? 12 have 1, 2, 3, 4, 6, and 12 itself as a factor. How come? When we are dividing 12 by 1, we will get 12, right? And there is no remainder. Same thing with the 2, we will get 6 and no remainder. When we divide it with 3, we get 4 and no remainder. When we divide 12 by 4, we will get 3 and 0 remainder. And when we are dividing 12 by 6, we get 2 as the quotient as 0 and the remainder. And 12 divided by 12 is 1 as the quotient as 0 remainder, right? So these are factors. Let's take another example. Let's say this is number 36. So what are the factors of 36? We could write 36 as 1 into 36, right? Or we could write 2 into 18, right? Now we could write it as 3 into 12, right? Or we could write it as 4 into 9, right? Now these are a few examples of factors. So factors of 36 could be written as 1, 2, 3, 4, 9, 12, 18 and 36, right? Now after this, there's a very simple concept called prime factors. So if these are the factors of a number, the prime factors are only the prime numbers which are the factors of the number. Just like we wrote 12 as 2 into 2 into 3 or 2 into 3 into 2, right? These are all numbers which are prime. So the prime factors of 12 would be 2, 3, right? 2 and 3 are the prime factors of 12. Now what are the prime factors of 36? Let's see. We could write 36 as 3 into 12, right? So 12 can be written as 3 into, what is 12? Let's take this, 2 into 2 into 3, right? These are the prime factors. Let's multiply this. We'll get 2 into 2 is 4, 4 into 3 is 12, and 12 into 3 is 36. So these are called the prime factors of a number. Now what are multiples? A set of number which are exactly divisible by the given number. So what are multiples? So what are the difference between factors and multiples? If we look at the statement very closely, we'll see that factors are the numbers which exactly divides the given number. So basically a number is dividing the given number, right? So what is multiple? Multiple is a set of number which are exactly divisible by the given number. So in this case, the given number becomes the denominator, right? So what are the multiples of 12? We could say 12 itself is a multiple of 12 because 1 into 12 is 12, right? Now 2 into 12 is 24, right? We have 3 into 12, which is 36. So 12 into any number gives this number, right, which are multiples. So a set of number which are exactly divisible by the given number, that is 12 by 12 is equal to 1, 24 by 12 is equal to 2, 36 by 12 is equal to 3. So any number, these numbers are called the multiples of a number, right? Here the multiples of 12. Now here is an interesting fact. The factors of a number can help us find its multiples. So how are they related? Well, if a number have 4 factors like 2 and 5, then its multiple will be numbers that are products of 2 and 5. So the multiples of the number would be 2 into 5, which is 10, 2 into 2 into 5, which is 20, 2 into 2 into 2 into 5, which is 40, and so on. So basically, we got a number with the factors 2 and 3, right? Here the factors are 2 and 3. So here we got 12, and we know that the factors are 2 into 3, right? Now what are the multiples of these number? Multiples of these number would be the combination of these two numbers 2 and 3. So 2 into 3 is equal to 6. Is 6 a multiple of 12? Yes, it is, because 6 by 12 gives us 0.5, right? Or we could ignore that and we could take 2 into 2 into 3 into 2. Let's say this is 12 and 12 into 2 is 24. 24 by 12 is actually 2. So these are the multiples. Now I hope the relation between factors and multiples are very clear. Now let's move on to common multiples, right? A common multiple of two numbers or more than two numbers is that number which is exactly divisible by both without leaving a remainder, right? So let's say we have two numbers 8 and 16, right? Now what are the common multiple of these numbers? Let's see. When we are writing 8, we are factorizing 8, or we are writing the factors of 8. We could say 8 is 4 into 2, right? Or 8 into 1, anything. Now what is 4? 4 is 2 into 2. So 4 is 2 into 2 and we have a remaining 2, right? And what is 16? 16 is 8 into 2, right? So this is 8, which is 2 into 2 into 2 is 8, into 2 is 16, right? So what are the common multiples here? It's 2 is common here, again 2 is common here, again 2 is common here. So 3 times 2 is common here, that is 2 into 2 into 2, that is 2 2s are 4, 4 2s are 8. So 8 is the common multiple between these two numbers, 8 and 16. How come? This is 8 into 1 and this is 8 into 2. You know, we are just taking a very simple example here, which is 8 and 16. Everybody knows that 8 is the common multiple, right? Now, when we have two different numbers, let's say we have 48 and 36, right? So, what is the multiple of 48? How do we find the multiple? There's an easier way to find the multiple or factors, right? We have to find the factors. There's an easier way to find the factors of 48. What do? We just write 48 here. We draw a line, right? Now, let's see the smallest prime number which can divide this completely. So 2 is the smallest prime number, right? We have 2 2s are 4 and 4 2s are 8, right? Now again we can divide it by 2 and we'll get 12. Again by dividing by 2 we'll get 6. Again by dividing by 2 we'll get 3, and by dividing by 3 we'll get 1. So what are the prime factors of 48? We have 2 into 2 into 2 into 2 into 3. Let's calculate this. 4 2s are 8, 8 2s are 16, and 16 into 3. 6 3s are 18, 3 1s are 3 and 4. So we got 48 here. Same way we'll find the factors of 36. You know, this could be done in another way where we write 36 is equal to 12 into 3, right? And 12 is 4 into 3, right? Now, what is 4? 2 into 2. We split it, right? 4 is 2 into 2 into 3 into 3. That is 2 2s are 4 and 3 3s are 9. We get 36, right? Same thing could be done here. We divide it by 2. I'll get 1 2s are 2, 1 6, 18. Now, again by 2 we'll get 9. by 3 we'll get 3 again, and again dividing by 3 we'll get 1. So it's 2 into 2 into 3 into 3. 2 into 2 into 3 into 3. So let's choose the common things here. We have 1, 2 common, right? The second 2 is also common. Now we have 1, 3 common here, right? So we have 2 into 2, 4, and 4 into 3. We get 2 into 2 into 3. So 4 into 3 is 12. So the common multiple here in 36 and 48 is 12. Now let's move on to the next topic, which is highest common factor or HCF. So imagine you have two numbers like 12 and 18. The HCF is the biggest number that can divide both 12 and 18 exactly, leaving no remainder. It's like finding the largest common factor they both share, right? So we have 12 and we have 18. So we have to find the highest common factor of both of these numbers. So what are the factors of 12? We could write 12 as 4 into 3, and 4 could be written as 2 into 2, right? So 12 could be written as 2 into 2 into 3. Now while we are looking at 18, 18 could be written as 9 into 2, and 9 could be written as 3 into 3. So 18 becomes 3 into 3 into 2, right? So let's actually find the common factors here. We have 2 and we have 3. So 2 into 3, which is 6, becomes the highest common factor here. So this is how we find the highest common factor of two numbers. Now let's find the two methods of finding the HCF. The first one is just explained right now, which is actually the prime factorization method. So 82 could be written as, let's do the prime factorization, 41, and 41 is 0. So we have 2 into 41, and then 48, we'll do the prime factorization, we'll get 2, and 24, again by 2 we'll get 12, again by 2 we'll get 6, and 3 we'll get 2, right? Again by 2 we'll get 1. So 48 can be written as 2 into 2 into 2 into 2 into 3. So what is the highest common factor here? It's 2. Now let's move on to the next method, which is the division method. So division method is the easiest method to find the HCF of a number. So let's say we have two numbers just like this, which is 48 and 82. We have 48 and 82. What we do is we take the highest number or the greatest number to be the dividend. So 82 becomes the dividend and 48 becomes the divisor. So how many times 48 is very close to 82? So what is 48 into 2? We'll get 96, which is greater than 82, right? So we'll take 1 times 48, then we subtract it and we'll get 34, right? Now what we do is we change the divisor and the dividend. We place 48 as the divisor and 34 as the dividend. Now how many times 48 is 34? Now 34 into 2 is 68, which is greater than 48, right? So we'll do 1 times 34 and we'll subtract it, we'll get 14, right? Again 14 is taken as the dividend and 34 is taken as the divisor. So 14 into 3 gives us 42 and 14 into 2 gives us 28. So here we could take 2 as the quotient and we'll get 28. We subtract this and we'll get 6, right? Now we have 6 as the divisor and 14 as the dividend. So 2 6 are 12 and we'll get 2 remainder. Now we'll take 6 as the divisor and 2 as the dividend and we'll get 3, 6 and 0. So which is the divisor which actually gave us the remainder 0? 2. So 2 is the HCF of both of these numbers. Now HCF of a polynomial. So what are polynomials? Polynomials are actually things which have a variable, right? More than one variable? No, I mean it could be more than one variables and more than one constants, right? So anything which is in the form of ax square plus bx plus c could be written as a polynomial. So, how do we find the HCF of a polynomial? First, we need to find all the factors of each polynomial. Factors are the numbers that can divide the polynomial without leaving any remainder. Then, we'll do the same for the polynomial. Now, we have to find the common factors in both of these polynomials. These factors are that both polynomials share. Now we find the common factor, which is the highest common factor in both of these numbers, and we find the HCF of a polynomial. It's basically the same that we do in the prime factorization method with the numbers. So instead of numbers, we'll have polynomials here and we'll find the highest common factor amongst them. Let's move on to the next method, which is explained here, which is the least common method. So in here, we find the least common multiple of two numbers. So what are least common multiples? So we talked about what are multiples, right? So if we have 12 as a number, we have 24 or 12 itself, 24, 36 and 12 into n as the multiple of this number. Now we take another number, let's say 8. So what are the multiples of 8? We have 8, 16, 24, etc. as the multiple of 8. So what is the least and common multiple in between both of them? Here we could see that 24 is the least common multiple, right? So how to find these numbers? Like 12 and 8 are very familiar number to us and we know what are the tables of 12 and 8. So what if we get a number like 1482 and 394? So how do we find the least common multiple of both of these numbers? So one method to find both of them is the prime factorization method again. So in here, rather than HCF, we could write both of these numbers together separated with a comma, right? So we have 1492 or 1482 and 392. So let's do the prime factorization. We know that they both are divisible by 2 as they both are even. We have 741 and 1, 9 and 6. So again, one of these numbers is divisible by 2 and the other is not. So we will divide the number by 2, but we'll keep the other number intact. So we have 741 and we have 98. Again, 741 is not divisible by 2, but 98 is. So we'll do the same where we'll keep 741 as it is and we'll do the next one, which is 49. Now, both of these numbers are not divisible by 3. No, 2. Now, is it divisible by 3? So, 9 plus 4 is 13, which is not a multiple of 3. So, it's not divisible by 3. Now, 7 plus 1 is 8 and 8 plus 4 is 12. So, 12 is a multiple of 3. So, this can be divided by 3. We have 2 3s are 6, 4 3s are 12 and 7 3s are 21. We have 49 as it is. Now again, let's check whether this number is divisible by 3. So 7 plus 4 is 11, 11 plus 2 is 13 and it's not divisible by 3. So we have 247 and 49. Now 49 is divisible by 7. What about 247? So 247 is not. So we'll keep 247 as it is and we'll take 7 here. Now again with 7 we'll get 247 and 7. Now, what is the LCM of both of these numbers? To find the LCM of both of these numbers, we just multiply everything on the left hand side. So, we have 247 here and 1, 1. So, the LCM of both of these numbers would be 2 into 2 into 2 into 3 into 7 is multiplied 3 times. So, it could be written as 7 cube and we have 247. So by using prime factorization method, this is how we find out the LCM of a number. Now the same goes on with division method. We have two numbers, let's say 48 and 32. Now we'll divide it with prime factors. Any of the prime factors we could divide it with 2. Now we'll get 24 and 16. Again we'll divide it with 2. We'll get 12 and 8. Again by 2 we'll get 4 and 2, 4 and 6. So again by 2 we'll get 3 and 2. Again by 3 it will get 1 and 2. By 2 we'll get 1 and 1. So the LCM of these numbers would be 2 5 times, that is 2 raised to 5 into 3. Now, another way of doing the prime factorization method is we write the multiples of these numbers, or we write the factors of these numbers just as in such. So let's say we have 12. 12 could be written as 4 into 3, which could be further written as 2 into 2 into 3. And let's say we have another number which is 49. 49 could be written as 7 into 7. So this is the prime factorization of 49. So do we have anything in common here? No. We have 2, 3 and 7. So we multiply everything. We have 2 into 2 into 3 into 7 into 7. So 49 and 12. We just multiply it with each other and we'll get the LCM of these numbers using the prime factorization method. Now, another property which is a very important property of HCM and LCM are, if we are taking two numbers and we are saying that this is the HCM, HCF of the number and LCM of the number, the product of HCF and LCM of the number would be equal to the product of these two numbers. So again, let's take an example which is 8 and 14. So what is the LCM of 8 and 14? To find LCM, I'm taking the division method, putting on 8 and 14 here. So by 2 we have 4 and 7. Again by 2 we have 2 and 7. Again dividing by 2 we have 1 and 7. And dividing by 7 we get 1 and 1. So this is 2 cube into 7, which is 8 into 7, which gives us 56. And let's find the HCF of these numbers. To find the HCF, either we could do the multiples or prime factorization method, which is easier this way. We have 8, which is written as 2 into 2 into 2, and 14, which could be written as 2 into 7. So 2 is the highest common factor here. So HCF would be equal to 2. Now what is the product of the given numbers? We have 14 into 8. 8 4s are 32 and 8 1s are 8. So 8 plus 3 becomes 11. Now we have HCF into LCM, which is 56 into 2. We have 12, 5 2s are 10 and 12. So this proves that the product of two numbers is equal to LCM of two numbers into HCF of two numbers. Now let's talk about LCM and HCF of fractions. Let's say we have two fractions and we have to find the HCF of two fractions. So how to find HCF of two fractions is that we find the HCF of the denominators and we divide it by the LCM of the numerators. So we have HCF of the numerators and LCM of the denominators, and when we have to find the LCM of two factors, we have LCM of the numerators and HCF of the denominators. So this is all about the chapter which is HCM and LCF. We talked about what are factors and what are multiples. We talked about the common multiples of a function of an equation. Then we talk about the highest common factors, then methods of finding the highest common factors, which is the prime factorization method and the division method. Then we talked about how to find an HCF of a polynomial, then about the least common multiple or LCM, and then the methods to calculate LCM, which is the division method and the prime factorization method again. And then we talked about a very important property of HCF and LCM, which is the product of two numbers is equal to the LCM of two numbers and HCF of two numbers. Then we talked about how to find the HCF and LCM of fractions, that is HCF of two fractions is equal to HCF of numerators divided by the LCM of denominators, and LCM of two fractions is equal to LCM of numerators divided by the HCF of denominators.